going to see LPP, shortly known as LPP, but abbreviated as linear programming problem by using simplex method. So this is one of the very fundamental method in LPP. This method is used for various other methods as a basic fundamental, like in begin method, revised simplex method, two-phase method, and other methods. So this is one of the very important methods in LPP. Now we are going to solve a simplex method, LPP by using simplex method, right? So this is the problem. Maximize z equal to 3x1 plus 2x2 plus 5x3 subject to the constraints. There are three constraints given. So x1 plus 2x2 plus x3 less than or equal to 430. Similarly, there are other two constraints and non-negativity conditions x1, x2, x3 greater than or equal to 0. These three components are put together called LPP. LPP will contain three components. First one is objective function. So Z is called the objective function, for which we are going to maximize or minimize the function. So suppose the cost is given, the expense is given, then we will have to minimize it. So suppose profit or sales is given, then we will have to maximize it. So here obviously we have to understand in such a way that the given equation over here is nothing but it is the profit. So we have to maximize the objective function. So in order to maximize the objective function, we have to look after or satisfy the condition. So some condition, in other words, called second component called constraints. Constraints may be any number of constraints. In this problem we have got three constraints. So constraints means it is the inequality sign. So it may be less than or equal to sign, or equal to sign, or greater than or equal to sign. But at the same time, in simplex method, fundamental simplex method, we will get only less than or equal to sign. Suppose greater than or equal to sign comes in constraint, then we will have to go for bigger method or other methods. So in simplex fundamental method, we can solve the entire constraints only by using less than or equal to sign. Therefore, all the three constraints will have less than or equal to sign. Then third component is called non-negativity constraints. What is non-negativity constraints? Non-negativity constraints means the value which are, we are going to find the values of x1 and x2, x3 at the end of the simplex method must be non-negative, which means either 0 or positive. So these three components are put together called linear programming problem. Right. Now we have to solve the problem. First of all, we have to convert the inequality sign into equality sign. Suppose less than to be converted into equality, obviously we will have to add some value to the left hand side. For example, 5 is less than or equal to 7, which means we have to add 5 plus 2, then only this left hand side must be equal to the right hand side value of 7. Therefore, we have to add that 2 to the left hand side. This 2 is called slack variable. So this 2 is called slack variable. In order to convert the less than or equal to sign into equal to sign, therefore we will have to add a variable to the left hand side is called slack variable. Why we are adding? Because whenever you will find equality sign, then only you will get a unique value. Therefore, I am going to convert the first equation by adding slack variable 1. Here we know the value what we are going to add over here, because 5 and 7 are known to us. Whereas here we don't know the value x1, x2, x3. We don't know the value. Actually, we are going to find the x1, x2, x3 value at the end of the problem. Therefore, we don't know the value. Therefore, we are variable value is also S1. Similarly, for the second constraint, S2. Third constraint, S3. So, therefore, we are adding 3 slack variables to the left hand side of all the 3 constraints separately so that the inequality will becomes equal sign. So 3 constraints will be converted into equation. Now all the variables, these 3 variables are called decision variables. Decision variables. The variables which are given in the problem is called decision variables. These variables will always must be 0, must be greater than or equal to 0. Similarly, what we are adding to the left hand side, in other words, it is called slack variable. They are also greater than or equal to 0. Now we will have to find the IBFS. IBFS means initial basic feasible solution. For finding the initial basic feasible solution, we will have to make all the decision variables into 0. So all the decision variables into 0 means x1 equal to x2 equal to x3 equal to 0. Now if we substitute these 3 values into 0 in the constraints, we get it from constraints. S1 equal to 430 because all the 3 variables are equal to 0. So S1 equal to 430, S2 equal to 460 and S3 equal to 420. This is called initial basic feasible solution of the LPP by using simplex method. Once you get the initial basic feasible solution, then only you will be able to go into the first table. Now first table. Take the initial feasible solution first. S1, S2, S3. So values of S1 is 430, 460 and 420. So what is CB? CB is nothing but cast in the basis. B for basis, cast. So CB of x1 which is there in the so since slack variable does not have any profit, therefore it is assumed that 0 into that particular variable. So maximize z equal to 3x1 plus 2x2 plus 5x3 plus 0x1 s1 plus 0s2 plus 0x3. So this is called the coefficient of the corresponding variables are called cast. So cast is 3, x2 cost is 2, x3 cost is 5. So S1 cost is 0, 0, 0. So you have to carefully watch the first table. How I am filling the first table, that is very important. Okay. Now the cost of S1. Cost of S1 is nothing but 0. So first table is much easier than the upcoming tables. Okay. Right. Now I am going to write the constraint values, constraints coefficients over here. Which means, take the first equation. What is the coefficient of x1? 1. So put 1 over here. Similarly, what is the coefficient of x2? 2. So put 2. Similarly, x3? 1. For the second equation, x1, coefficient of x1 is 3. There is no x2 variable in the second constraint, so put 0. x3 coefficient of x3 is 2. There is no s1. s2 is 1, 0. Similarly for the third equation, 1, 4, 0. No s1, 0. No s2, 0. So 1. You learn to ensure that it has to be formed. The unit matrix has to be formed in each and every simplex table. I will tell you why in the later part of the problem. Okay. Right. Now I have to find the Zj minus Cj. What is the Zj minus Cj? Cj is nothing but the cost for the first column. So cost for the first column is 3. Cost for the second column is 2. Cost for the third column is 5. Similarly, cost. What is Zj? Zj is nothing but it is a combination of 2 or 3 arithmetic operations. For example, what is Zj? Zj is nothing but 0 into 430, 0 into 460, 0 into 420, which means you have to multiply the cost with the actual coefficient elements, corresponding coefficient elements, and then add those values. For example, for first table, it must be very easy to understand. for the second table we will have to calculate. I'll tell you, sorry. So 0 into 430 0. 0 into 460 again 0. 0 into 420 again 0. So you will have to add all the three values so that answer is 0. You have to subtract the cost over there. There is no cost for IBFS, therefore Z star equal to 0 for the first table. Similarly, for each and every column we are going to find. For each and every column, 0 into 1, 0, 0 into 3, 0, 0 into 1, 0. Add all the zeros, you will get 0. 0 minus 3, because there is no cost in this column, but you will get a cost in the first column. Therefore, 0 minus 3 equal to minus 3. Similarly, 0 minus 2 equal to minus 2. 0 minus 5 is equal to minus 5. 0 minus 0, 0. 0 minus 0, 0 minus 0. So, you will be able to understand what I am saying. I repeat once again. You will have to multiply the cost with the corresponding element. Then add all the three elements. Finally, you will have to subtract the corresponding cost. So that you will get Zj minus Cj for every column. Right? That is why I am telling first table is much easier compared with the upcoming tables. Okay, this is much easier because all the values are 0. So when you are multiplying, you will get 0 only, right? Now I am going to find, after getting the 6 value over here, I am going to find the which is going to be the most negative value. What is most negative value? So I have to pick a value, negative value, out of which number is highest, which means 5 is the highest whose value is negative. So most negative, this is called most negative value, or rather in other words we can say that lowest value. So in negative, 2 is the highest value, minus 5 is the lowest value. So you can put whatever you want to. So most negative is minus 5, which means x3 is going to come inside the table for the next table. So incoming vector, incoming variable is equal to x3. So once x3 is coming in, out of these three variables, any one of the variables will be going out of the table. So what is the variable which is going to be out? That is why we are going into the last column of this table. What is it? Minimum ratio. So I am going to find the minimum ratio of the three constraints. So which means 430 is the answer column. So 430, ratio means divide. Okay. Similarly 460 divide by 420 divide by, okay, by which number? Incoming column number, corresponding incoming column number. So which means 430 divided by 1, 460 divided by 2, 420 divided by 0. Once you will get 0 and a negative, you should not get the value. Therefore put the dash, simply dash. So you should not take it into the consideration for finding minimum ratio. Now 430 by 1 is 430, 460 by 2 is 230. So heading itself minimum ratio, we have got 3 ratios, out of which one is invalid. So balance 2 values are there, 2 ratios are there, out of which I am going to find the minimum ratio. So 230 is the minimum. So that is going to be out of the second table, which means S2 is going to be outgoing vector. S2 is outgoing, X3 is incoming. Sorry. So now I am going into the second table. There is no change in S1, there is no change in S3. So put 0 over here, 0 over here. What is the new change? Instead of S2, X3 is coming. Instead of S2, X3 is coming. What is the cost of X3? Cost of X3 is 5. 3, 2, 5, 0, 0, 0. So cost of X3 is 5. So put 5 over here. So you have to understand the transition from first table to the second table. That is very, very important. Now I have to find the pivot element. What is pivot element? Pivot element is otherwise called leading element. I am going to find the second table by using the single element called pivot element. That is why it is called a leading element. Based on that element only I am going to form the second table, which means minus 5 incoming vector, 230 is the outgoing vector. Both the lines are joining at a point is called pivot element. Both the incoming and outgoing vector joining point, junction is called pivot element. So it is joining at the point 2. Therefore 2 is called pivot element. You can also write over here pivot is 2. So I am going to convert the pivot element into 1. That is the next process for me. So pivot into 1 means you will have to divide the entire row by 1, because it is in the form of an equation. You cannot divide the 2 alone. You will have to divide the entire row by 2. Therefore 460 by 2 is 230. 3 by 2. Don't put 1.5 like that. Put 3 by 2. 0 by 2 is 0, 2 by 2 is 1, 0 by 2 is 0, 1 by 2 is 1 by 2 and 0. Now next step, what I am going to do is, I just wanted to convert the remaining elements in that column must be equal to 0. That is the step number 2 and 3 for the simplex table 2. Transition is very important, I already told you. Transition. First we will have to convert the pivot element into 1. After that, the corresponding element in that column. Corresponding element in that column means this value and this value must be equal to 0. We have to convert those two values must be equal to 0. So fortunately for us, one value is already 0. Therefore, we don't have to change the entire equation. We can directly write it. So 420. 1, 4, 0, 0, 0 and 1. Therefore, one operation is being done already, because already 0 is there. Therefore, we don't have to change the entire equation. But now I am going to change this 1 into 0. So what I will give you a small tip that whatever may be the number over here, you just take the opposite number. Multiply with that. For example, here 1 is there. You will have to take the opposite number, minus 1. Multiply with that. So minus 230, minus 3 by 2, minus 0, minus 1, 0, minus 1 by 2, 0. Whatever may be the number you want to convert it into 0, take the opposite of it. Take the opposite of it. Take the opposite of it, then multiply it with the pivot element row, new row. Just a minute. So this this must be equal to 0. So multiply opposite number, you will get the minus 230, minus 3 by 2, 0, minus 1, 0, minus 1 by 2 and 0. Now you will have to add that number with the actual equation, what you are going to convert it. So I am going to convert this one into 0. So corresponding equation is 430, 1, 2, 1, 1, 0, 0. This is the shortest form. You can easily remember. So you just add these two values. So 430 minus 230 equal to 200. 1 minus 3 by 2 is equal to minus 1 by 2. So 2 plus 0 is 2. 1 minus 1 is 0. 1 plus 1 is 0. So 1 plus 0 is 1. Minus 1 by 2. 0 plus 0 is 0. Now, that's all. I have made the entire simplex table 2. All the data available. Now, I am going to follow the same procedure that I followed in the table number 1. So, what is the procedure? You have to multiply it with the corresponding cost factor. Multiply, then add. So 0 into anything 0, 0 into anything 0. So the only number you will get from the second row. Therefore 5 into 230. This is equal to 5 into 230. 0, 5 3s are 5, 15, 1, 1, 1, 5, 0. Next 5 into 3 by 2. 5 into 3 by 2 is 15 by 2. 15 by 2 minus 3. 9 by 2. So 5 into 0 is 0 minus 2. So all the remaining values must be equal to 0 because there are 0, cost is 0 for S1 and S3. Therefore all the values which are multiplied by the cost 0 for the first row and third row equal to 0. Therefore you can add those two values must be 0. So only non-zero value you will get from the second row. Therefore 5 into 3 by 2, 15 by 2 minus 3. 15 by 2 is nothing but 7.5, right? 7.5 minus 3 is equal to 4.5. 4.5 is nothing but 9 by 2. So 5 into 0, 5, 0, 0 minus 2 is minus 2. 5 into 1, 5 minus 5 is 0. 5 into 0, 0, 0 minus 0 is 0. 5 into 1 by 2 is 5 by 2. Minus 0 is 5 by 2. 5 into 0, 0, 0 minus 0 is 0. Now once again I am going to find the most negative. There is only one negative, therefore there is no comparison. You will have to take that negative. So obviously x2 is going to come into the next table. Then I have to find which one is going to be out of the table. So corresponding 200 divided by, similarly 230 divided by 420 divided by, which value you will have to divide the corresponding incoming vector column value. So 200 divided by 2 equal to 100. 230 divided by 0 you cannot find the value because it is invalid. 420 divided by 4, 105. So minimum is 100. So x1 is going out, s1 is going out. Instead of s1, x2 is coming in the next table. Now I am just created last table from which you will get the final value. So you will not get CB is 3, 2, 5, 0, 0, 0. Now S1 is going out. Therefore, instead of S1, X2 is coming in. So X2, there is no change in X3 and S3. So cost of X2 is 2, cost of X3 is 5, cost of S3 is 0. Zj minus Cj. Now Z star, that is the answer. Now I am going to convert, please come over here. I am going to convert this pivot element. What is pivot element over here? Incoming vector, this is, and outgoing vector, this is. Joining point is 2 again. So 2 is pivot elements. I am going to convert that 2 into 1, which means you have to divide the entire value by its pivot element. So 200 by 2. 200 by 2, 100, minus 1 by 2 by 2. So minus 1 by 4, 2 by 2 is 1, 0 by anything 0, 1 by 2, minus 1 by 2, minus 1 by 4, 0. Now, I have to convert the corresponding elements in that column must be 0. So this must be 0, this must be 0. I will have to convert these two values into 0. But fortunately for us, already 0 is there. Therefore, there is no change to convert it. You can directly write it. So 230. 3 by 2, 0, 1, 0, 1 by 2, 0. Now I am going to convert to the 4 into 0. So I already told you 4. Take the opposite number. What is the opposite number of 4? Minus 4. Multiply with the pivot element row. Table 3, simplex table 3. Minus 4. Multiply all elements with minus 4. So minus 400 plus 1 minus 4, 0, minus 2, minus plus 4 can get cancelled, 1, 0. So you can add with the what we are going to convert. So I am going to convert this 4 into 0. Therefore, take the third equation as it is. 420, 1, 4. So 420, 1, 4. 0, 0, 0, and finally 1. So you add these two values. 420 minus 400 equal to 20. 1 plus 1 is 2. 0, 0, minus 2, 1, 0. Sorry, 1. Okay. Now I just using the same, process what we have followed in simplex table 1 and 2. So multiply with the 2 into 100, 200. 5 into 230, 1150. 0 into 20, 0. Add. So 1350. Similarly, 2 into minus 1 by 4. Now minus 1 by 2. 5 into 3 by 2. 15 by 2. Minus 3. So 14 by 2 minus 3. So 14 by 2 is 7. 7 minus 3 is 4. Similarly, next 2 into 0, 2. 5 into 0, sorry, 2 into 1, 2. 5 into 0, 0. 0 into anything, 0. Minus 2. So 2 minus 2 is 0. Next. 2 into 0, 0. 5 into 1, 5. 0 into anything, 0. Minus 5. So 5 minus 5 is 0. Next. 2 into 1 by 2, 1. 5 into 0, 0. 0 into anything, 0. 1 minus 0, 1. Fifth column. 2 into minus 1 by 4, minus 1 by 2. 5 into 1 by 2, plus 5 by 2. 0 into anything, 0. Minus 0. So 5 by 2 means 2.5. 2 and half. 2 and half minus half equal to 2. So last one. 2 into 0, 0. 5 into 0, 0. 0 into anything, 0. Put together 0. Minus 0, 0. Therefore, now I have to find the most negative. Fortunately, or we don't get a negative over here. Therefore, we cannot proceed for the third table. Only if you are getting negative value, then only you will be going to the next table. So you don't get negative value, obviously you can stop. We get optimum solution. So all Zj minus Cj, which is greater than or equal to 0, then we get an optimum solution. What is optimum solution? The solution is going to be maximized by the simplex method. Okay, it's called optimum solution. Okay, so how do you find the optimum solution? Maximize Z equal to 1350 when x1, I will write a decision variable x1, x2, x3. So what is x1? There is no x1 in the answer column. Therefore, put the x1 equal to 0. x2 equal to 100. So x2 equal to 100. x3 equal to 230. That's all. So I am going to get the optimum solution for the given LPP is maximized Z value is 1350 when the decision variables are x1 equal to 0 and x2 equal to 100, x3 equal to 230. This is the final answer. This is called optimum solution. So you are getting the maximized profit for the given problem of LPP. So you can also check with the answer whether the answer is correct or not. Okay, it will take just 2 minutes. Okay, that's all. We solve the problem. You will get definitely you will get one question from that this method. Okay, so x1 equal to 0. Put so x1 equal to 0. Okay, x2 equal to 100. 2 into 100, 200. x3 equal to 230. So 1150. 1150 plus 200 equal to maximum Z 1350. So you get it. And also you can check this constraints. So x1 is 0, x2 is 100, 2 into 100, 200, x3 is 230. What is s1? There is no s1 in there. S1 is slack variable. We only added this variable. Therefore, you should not include in the answer. That is why I did not include in the answer. Okay, right. So s1 is not there. Therefore, 0. So 200 plus 230 equal to 430. So answer is correct. What we have found is correct. And also you can check the second and third constraints. So 3 into x1 0, 2 into x3 200 plus s2. 3 into x1 plus 2 into x2 plus s2. s2 is 0. So 200 must be less than or equal to 460. So next check. Oh, sorry. One second. Sorry. 2 into x3 value. This is not x2, x3. x3 is 230. So 2 into 230 is 460. So answer is correct. So next x1 is 0, 4x2. x2 value is 100. So 4 into 100, 400 plus s3. s3 value is 20. So plus 20 equal to 4. So what we have found in the answer, and also you can check the non-negativity constraints. All the variables, both including decision variables and slack variable, must be greater than or equal to 0. So what we have got is greater than or equal to 0 over here. including slack weight. Thank you guys.